At ACES, we are involved in the design, discovery and development of new materials. We use additive fabrication approaches to enable the implementation of those materials in areas of energy and medical technologies. This highly interdisciplinary collaborative research environment that is globally connected provides an excellent research training ground. Let me introduce you to Alex. Okay, so Alex, what brought you to Wollongong?
So I spent 3 months doing a project here with Paul Molino as part of my undergraduate final project. I found that the institute was really interesting, and so I applied to do a PhD with Professor Michael Higgins. A lot of the skills you can get here are all to do with how you investigate materials, and so a lot of what I've worked with is scanning electron microscopy, and that sort of thing is really useful to investigate nanomaterials, different chemistries as well, if you're looking at things like that.
And you were involved in the development of a completely new fabrication approach, taking 3D fabrication into the nano domain. Yeah. What do you consider to be the most significant achievements to come out of that?
So this tool is to generate suspended nanofibers, and these fibers our goal initially was to try and generate the kind of structures you have in your brain. So these nanofiber structures in your brain are made of proteins and sugar proteins. And to reproduce that, we developed this system to suspend it in 3 dimensions. And then we took that into a gel. And so I think that's the main goal and application for the technology. Further on, I think maybe it could also be used for electrostimulation if we can get some kind of conductive fibers working with the system. I think that would be really useful in tissue engineering.
So you've created a fabrication tool that enables you to assemble 3-dimensional, nano-dimensional structures inside a biocompatible gel.
Yeah, so what we do is we generate the fibers using near-field electrospinning on 3D electrodes, and these electrodes allow us to suspend these 3-dimensional fibers, and we take those fibers and then we incorporate them within a biocompatible gel. I think that's the main goal in tissue engineering, is to reproduce the tissue, and this we think is now approaching the hierarchy of things, so from the macro domain in the gels down to the nano domain in the fibers.
Great.
So, yeah.
And so within that highly collaborative interdisciplinary project, you as an individual must have accrued a range of technical skills.
The main thing I enjoyed and main thing I had fun with the whole system was developing these computer-aided design models, generating the final structure and having the whole thing come together. I think that was the main skill. A lot of SEM work as well. I developed my ability to communicate far more effectively giving presentations, and maybe another one was probably discipline. I think that's what a PhD makes you do. If you're not organized and you can't develop a plan, it's not going to come together ever.
So what's the ideal career development pathway for you going forward?
So additive manufacturing is really exploding in all sorts of ways, where there's like light additive manufacturing, where it generates the structure almost instantaneously, it seems to be. And so I think that's going to be one aspect. Another aspect is trying to get it to work in space. I think that's where 3D printing is going now. It's getting into the domains of where it's high technology and it comes together. So multi-axis print heads are coming together as well. I think that's what's going to be new.
So it sounds like exciting times ahead for 3D fabrication and for yourself.
I think so, yeah. I think it's going to be exciting. I'm really looking forward to it.